Hello everyone. This is Arun Saraf from Department of Earth Sciences, IIT Roorkee, and we are going to start a new course on Introduction to Remote Sensing. Earlier, I have also done a course on Introduction to Geographic Information System, and I would like to link these two courses with a technology word which is called geoinformatics. And geoinformatics constitute three technologies. One is remote sensing, another one is GIS, that is Geographic Information System, and third one is nowadays very popular is a navigation system or global positioning system. Now these three technologies are having three things in common. First of all these three technologies are digital. Secondly, they are spatial technologies. That means they are all related with the location specific data handling and other things. And third one, all these three technologies are generic, and that means that you can apply to as one can think the application area. So that is the best thing, is that all these three technologies are getting nowadays integrated with other technologies like communication and other things, and overall these technologies are becoming very powerful tool for in natural resource management, disaster management, and so many other applications. So first, as I mentioned that we are going to now discuss all this subject, that is remote sensing, in detail in next 20 lectures. So first we will see that what is basically remote sensing technology. We know that if we go by the definition, that is acquiring information or data about the Earth's surface without actually being in contact with it. And the best example of remote sensing are our eyes. We many things we observe through eyes without even touching them. But our eyes are not sensitive in all parts of electromagnetic spectrum. Our eyes are only sensitive in visible part of electromagnetic spectrum, and therefore we use, as human, we use a very small window of electromagnetic spectrum, which we will see in later lectures in detail. But there are some animals and birds which are more sensitive in other parts of electromagnetic spectrum, and one we consider as mammal, and that is your bat, which has got a different kind of remote sensing. It is having different kind of remote sensing technology. That means it senses the echo pulses, and whatever in return it records it, and based on that it basically make the assessment about it prey. So this is how it works. So our eyes are only sensitive in visible part, not in infrared or thermal infrared. That means through distance, by looking a object, we cannot assess the temperature of that object unless we know some other background information. And this is as you know that nowadays various types of satellites are in space, and what these satellites are doing, basically they are recording whatever the reflected or emitted energy. For reflected energy you basically require some source, and the best source for us is available is the sun. So sun during daytime it illuminates the part of the earth, and then whatever the reflected energy which reaches to the satellite is recorded. Emitted energy is as you know that all natural objects which are having temperature above absolute zero also emit energy, and that energy can also be recorded in thermal part of electromagnetic spectrum. So that we will see little later. And in overall remote sensing, what we do recording of the reflected or emitted energy. We do the processing. Remote sensing also involves the analysis of remote sensing data, and finally it is and last that not the least is the application part. How to apply, how to use this data set, which is a huge data set now is available from various types of satellites for, as I have mentioned, for natural resource management, disaster, civil engineering, you name it, nowadays people are using for various applications. So first, as you can see here, that there is a illumination source which is sun is available to us, and then we are having a satellite, and there might be a different type of satellite, then we are having a ground station, and then we are having recording facility, analysis facility at the ground. So first, as I have mentioned, for this reflected remote sensing, you require energy source, that sun is available for us, and then radiation and the atmosphere in between, we are having between the earth and the sun, we are having these phenomena, especially the atmosphere, and then whatever the interaction it has with different objects. Like for example, if the solar energy is falling on water, it will have different reflectance. If it is falling on the bare ground, it will have different. If it is on vegetation, it will have different. So the interaction with target is also important, and that makes the basis of basically the image making and image interpretation and analysis. And this what we do after this reflection, and then again going through the atmosphere, finally it is recorded by the satellite, and these satellites then which are having different types of sensors, which we will see later, then this involves the transmission of data from satellite to ground earth stations of different satellites, and finally you do the processing and analysis. And of course interpretation and analysis are very important, because a lot of nowadays data is available, but not much analysis or interpretations are being done. And new innovations are always required, integration with other data sets are also required while doing interpretation and analysis. So this basically covers the entire remote sensing in a nutshell. And of course, as I have been mentioning, applications are there, people are developing, new applications are being developed very regularly, almost every day. As you know that within one day the current or the present day remote sensing did not start. It took a lot many years, and we will see the history as well. So that remote sensing is also considered when we are using helicopters or aerial aeroplanes, which is considered as aerial photography. And later on we started putting our sensors also there on the aeroplanes, and then we are having optical sensors or other sensors through the satellites and having different distances, like your helicopters might be at 300 meter, 400 meter or 1 kilometer, whereas aerial photography can be done from much higher in space. Then you are having the range, a very high distance from surface of the earth, about the satellites which are mainly polar orbiting satellites I am talking. Then might be sometimes there are having space shuttle missions, and which may not be at that height as 700 to 900, but maybe at between say 185 to 575. And then there are another for SAR interferometry or some radar remote sensing, we use airborne SAR interferometry. Nowadays one more thing we can add here is now these UAV unmanned vehicles are also being used in remote sensing as well. As I mentioned earlier that nowadays the earth is enveloped with hundreds of satellites launched by different countries. As you can see, the cluster of different satellites are there. Our INSET satellite is also here, and there are NOAA satellites which started in 70s, and then many satellites are there which this is FY1 to 3, FY2 to 4, these were the Chinese satellites, and so on and so forth. And there if you see carefully, you would find that there are 2-3 types of orbits are also shown at different distances. So this is just a representative that how earth is being enveloped by different types of satellites which are orbiting around the earth. Some of them might not be working now, but there are many more satellites which are working, which are not shown in this figure. Now as we progress further in this, that remote sensing process involves an interaction between incident radiation and targets of interest. And in this case, when we are having regular satellites orbits, the target of interest is being scanned on a very regular basis. Depending on the height of the satellite, depending on the spatial resolution of the satellite, these targets of interest are being recorded. And then this is exemplified by the use of imaging system. Most of these systems we are not having like a digital camera, like a snapshot, except in meteorological satellites like INSAT or these communication satellites, where we are having snapshots. Otherwise, we are having imaging system which scans line by line or part of the earth, and then transmit the data towards the earth. Through earth stations we record the data, we interpret the data, analyze the data, and make different applications. Now, as you can see that for this reflected remote sensing or passive remote sensing, we require a source of energy, which is sun is there, and there is a one satellite is shown, and this the energy of the sun has to travel from the atmosphere, through the atmosphere. It reaches on the different types of the objects which are present on the earth, starting from building, and may not be a very high building, then maybe the roads, bare soils, grass, water bodies, forest, and different types of objects are there. Then this reflected energy, reflected solar radiation has to go back again to the satellites through this atmosphere, and lot of changes might also occur, lot of errors may be introduced during this transmission of this reflected radiation from the earth toward the satellite. So that is also how to correct it, how to improve our images, that is also done in digital image processing of satellite data. So that is also part of remote sensing. Now, as one by one we will go about that the A is the illumination source, which is shown there as a sun, that the first requirement for remote sensing is to have an energy source. Without that energy source, we cannot have illuminations, or we cannot have recordings of any target of interest. And as I have also mentioned that if you do not have the illumination source, then natural emittance or natural emission of energy which is coming out of different objects may also work there. So that is also there. Then we are having the radiation and atmosphere, as I have mentioned that the solar radiation which reaches to the earth has to go back to the satellite through again the atmosphere. So there is a B component which is shown in this figure. As the energy travels from its source to the target, it will come in contact with and interact with the atmosphere. So initially it will interact, then it passes through, and this interaction may take place and may take few seconds as energy travels from target to the sensor. So we are more concerned when our solar radiation or reflected energy is going back from the earth's surface towards the satellite, because that is what it is recorded by the satellite, and that is what it creates the problem for us. Suppose if there are clouds, so in during the daytime in this passive remote sensing, this reflected part, then the clouds will create problem, and what satellite will record clouds, not the part of the earth. So this is the major issue. So the atmosphere plays a very important role while this solar radiation, reflected solar radiation, reaching towards the satellite. Then the C component is the interaction with the target. So once the energy hits or the solar radiation hits the object, that makes it way to the target through the atmosphere, it interacts with the target depending on the properties of both the target and the radiation. Here the properties, as I have mentioned just 2 slides back, that whether this solar radiation is falling on a building or a bare soil or on rock exposures or water body or vegetation, it will behave differently, and therefore the signatures which it will reflect towards the satellite are also going to be different, and this makes the basis of our image, which will show these objects in different in digital values basically, and we assign to these digital values different colors So we see things in different colors. And the D component is the recording of energy by the sensor. Once the this reflected solar energy reaches to the satellite, it is recorded by the sensors which are present and the recording systems which are on board of these different satellites. So after the energy has been scattered by or emitted, as also mentioned earlier, that once this energy goes through the atmosphere to the satellite, it has to pass through the atmosphere, and this can create some problems, like there might be some absorptions, there might be some scattering and different types of scattering, which we will also see later, and which requires a sensor and remote not in contact with target to collect and record the electromagnetic radiation. So you require a complete recording system on board the satellite, and there are satellites also which not only records, but at the same time they also transmit the data towards the earth. So if you are having a appropriate setup for recording these data live almost simultaneously, once the part of the earth is being scanned by the satellite, the same time the data is being recorded by the satellite, and also it is directly being broadcasted towards the earth stations, and that can also be recorded. So immediately we get the data about that particular part of the earth for which the satellite is overpassing. And the last one here is the E component, that is transmission, reception and processing. So transmission is done by the satellite. The energy recorded by the sensor on board of satellite has to be transmitted or recorded. Then often it is in electronic form, that is in digital form. Then it has to be received by earth stations which are spread over the different parts of the earth in different countries. Processing stations, you require the data. So some initial processing is done, and later on some advanced processing or digital image processing of that data is also done. Some people may go for hard copies, or in nowadays most popular one is the digital image processing. Now after this you come for the F component, that is the interpretation and analysis. So the image which is recorded by the sensor on board of a satellite may not show initially the objects which one might be looking, or the differentiation between the objects, and therefore lot of processing is required. First processing is to correct, do the corrections of radiometric corrections. There might be some problems about the sensors, scanners, and those things have to be corrected. Generally these things are corrected by the operators of those satellites or earth stations. Then there comes in analysis part, there comes the how to remove the atmospheric distortions, because the reflected energy is going through the atmosphere, and this causes the lot of distortions in the data, ultimately in the images, and these have to be removed, so that our image becomes much more sharper, much more useful, interpretable. And then these are there are some other advanced image processing techniques which are applied, and ultimately we go for say pattern recognition or classification of images, and we prepare, like from using a satellite image we can prepare a forest density map, using a satellite image we can prepare a land use map, or maybe lithological map, a structural map. All kinds of maps then can be derived using remote sensing data. So we put all this in interpretation and analysis. And finally the G component, that is application, that is the most important one, is the data is there, every setup is there, but the data has to be applied, data has to be used somewhere. Now there are a lot of applications are there, people are employing data for your even weather forecasting, weather monitoring. If you are having the long term data, then climate change people are using the data, and for applications like simple preparing land use, land cover maps, for forest cover maps, for vegetation density maps, even for agricultural production, forecasting what is going to be the output through paddy crop or a wheat crop and so on and so forth, maybe in mineral exploration, maybe in oil exploration, water exploration. So, this is basically a long list of applications. Some of the applications still have not been developed or explored, and I am sure with more data and more type of different type of sensors, people will explore more applications of remote sensing as well. So, it depends where we, and the most important thing, whenever there is a disaster occurs, whether it is a flooding or earthquake or landslide, first thing people look for remote sensing data, and that is the true, a very good application of remote sensing. Because of these disasters, the first casualty is the communication. The communication becomes very weak or very poor, and therefore you have to do some, you have to find the information for a rescue and rehabilitation. Only that is possible nowadays through remote sensing. So, that is the data it is first looked for remote sensing data. So, this brings the basically in very brief the introduction of remote sensing. In this course, in next 19 lectures, we will be seeing all these things, components in much more detail. We will start with different parts of electromagnetic spectrum, and we will end with different applications. Few examples I will show that how remote sensing can successfully be employed for water resources, maybe for earthquake related studies and so on and so forth. So, thank you very much.